Right, hi Year 11. This is the feedback for your third home learning paper. Timestamps are in the description. Okay, number 1. So the rectangle has been divided into two strips A and B. The strips have the same width, and we've got 2/5 of strip A has been shaded and 5/8 of strip B has been shaded, and it says that the total length is 40 centimeters. What fraction of the rectangle is not shaded? And it says that A and B have the same width, which actually means what you can do is you can, if both A and B were 2, if both A and B were 7, if both A and B were 100, it's going to stretch it up and down. The overall proportion will be the same. So you might as well pretend that A and B are just 1. So what you can do is you can say that this is 2/5 of 40 centimeters squared. And this bottom one is 5/8 of 40 centimeters squared. What we can do is, of course, then figure this out. So 1/5 of 40 is 8. 2 times 8 is 16. So this is 16 centimeters squared. 1/8 of 40 is 5, and 5 times 5 is 25. So this is 25 centimeters squared. And if you add these up, so 16 add 25, you're going to get this total area. So this is 41, and it's going to be 41 out of the grand total. Well, the grand total will be 40, and 40 is 80. So that's the overall proportion that's shaded. So what fraction is not shaded is 39 over 80. Let's just check the mark scheme, see what they... So 39 over 80 is correct. And they just want you to do 2/5 of 40, 5/8 of 40, and then add them up. Yeah, so I mean, you can... That's the most straightforward way of answering that question. So anyway, 39 over 80. Okay, question 2. So we want to make W the subject of the formula. So I'll write P is W minus 3 all over 2. I want to get W by itself, so let's times up by 2. So you get 2P is W minus 3, and then I'll add 3 to both sides. So 2P plus 3 is W. So I'm going to write W equals 2P plus 3. Right, number 3. So we've got some distances, and we've got a speed, and it's asking about time. So we're definitely going to want to use speed is distance over time. So there's our little formula triangle. And we've got distance here is 25, so 25 for both. And we know what the speed is, it's 50 miles per hour. So for A to B, from A to B, we are going to work out what the time is. So the time is distance over speed. So I'm just using my formula triangle. If you cover up time, it's distance over speed. So the distance is 25 and the speed is 50. So this is 25 miles, and then it's over miles per hour. So this is going to give me 0.5 hours. And then from B to C, again, it's time is distance over speed. But this time it's 25 over 60. So I'll use my calculator for that one. So 25 over 60 is 5/12. So let me write it like this. It's 5/12, of an hour. We should really convert these into minutes though, and this is why I wanted to keep it as 5/12, because 5/12 of an hour is actually a nice number of minutes. So first of all, 0.5 hours, that's 30 minutes. 5/12 of an hour, well, that's 5/12 of 60 minutes, isn't it? So 5/12 of 60 minutes. So that's 25 minutes. And so the difference in the time is then just 5 minutes. Okay, next one. Right, solve the simultaneous equations, and then they're two linear simultaneous equations. We don't have the same number of x's or the same number of y's in both. Now there are two different ways of doing this. You can either choose to eliminate the x's or you can choose to eliminate the y's. I'm, just for the sake of answering this, I'm going to choose to eliminate the y's, but if you want to eliminate the x's, like, that's fine, you can choose to do either. So I'm going to make the number in front of the y's be the same. So I'm going to times the first one by 4, so I'll do 4 times equation 1, and that will be 16x plus 12y is minus 28. And I'll do 3 times equation 2, so I'll have 9x minus 12y, and then whatever 3 times 26 is, so again it's a calculator paper, so I'll just use the calculator for that, is 78. And then because this one's a plus and this one's a minus, you then want to actually add both of these together. So I'm going to add this and see what I get. So 16x add 9x is 25x. 12y plus minus 12y is just the same as 12y take away 12y, which is nothing, so that's the idea. We've gotten rid of the y's. And then minus 28 add 78 is 50. So that tells us that x has to be 2. And then to get what y is, you can substitute into any of these. So maybe I will substitute into this one. So I'm going to substitute into this one. So I'll have 4 times 2 plus 3y is minus 7. So that's 8 plus 3y is minus 7. So let's take away 8. You get 3y is minus 15, and therefore y is minus 5. Now, if you'd chosen originally to eliminate x, you would have done 3 times equation 1 and 4 times equation 2. And then instead of adding, you would have subtracted because they'd have both been positives. And that would have led you to work out what y was first. And you would have got y was minus 5 if you'd done it correctly. Then you would substitute y is minus 5 back into either of the equations and rearranged and gotten that x had to be 2. So you can either eliminate x or eliminate y. Doesn't matter. Right, number 5. £4,500, 2 years in a savings account, and we're paid 4% per annum, which means 4% per year compound interest. So what you want to do is you want to say it's 4,500 to start with. At the end of the first year, I'm going to have increased by 4%. So we've multiplied by 1.04 at the end of the first year. And then, well, we could work that out. I mean, like, I might as well show you what that is. We don't actually need to do this, but I'll show you what this is. So at the end of the first year, he's got £4,680. What do you then do at the end of the second year? Well, you increase by 4% again. So I would write times 1.04, and then you remember back when you did compound interest that, you know, you times by however many of these you need for however many years it is. So because it's 2 years, I'll times by 1.04 twice. So instead of writing it like that, I just put a 2 there because it's 1.04 squared. And so this little power is actually the number of years. So instead of timesing it by 1.04, I'm going to times it by 1.04 squared, which is £4,867.20. So then we've got 2,400 for n years in a savings account. This time we're paid 7.5% a year. So we're going to have 1.075. 7% increase is just 1.07, so 7.5 is 1.075. And we don't know what n is, but we do know that the answer to this is £3,445.51. So what we're going to do is we're just going to do some trial and error. So I'm going to do 2,400 times 1.075 to the power of, well, let's see, was it after 2 years? No. Was it after 3 years? No. Was it after 4 years? No, it looks like it's probably going to be after 5 years, doesn't it? 3, 4, 4, 5, 51. So it must have been after 5 years. Right, so there are actually more advanced methods to solve an equation like this, but not that you would do at GCSE. So in that situation, you are just using trial and error on your calculator. And of course, you could have gotten lucky and guessed 5 to begin with, and then you'd have been done straight away. Right, number 6. So we've got a shape. The dashed line is not part of the shape. So this is a compound shape with a semicircle glued to a right-angled triangle. It tells us this length here is 5, and the length across, so it's the hypotenuse of the right-angled triangle. It's also the diameter of the semicircle, and we're told that that's 8, and it wants the perimeter, so we want all of the sides added up, and at the moment we've only got one side. We've got 5 centimeters, and that's it. So let's figure out this side first, because why not? We could do this side first if we want to. We're going to have to do both of them. So this side here, we're going to use Pythagoras to answer that one. So, you're either good enough at Pythagoras to realize straight away that you do 8 squared, take away 5 squared, and then square root. Or let's label it ready for Pythagoras. So I might call this A, and this B, and this C, because remember the hypotenuse needs to be C. So I've got A squared plus B squared equals C squared. So that's 5 squared plus B squared equals 8 squared. So that's B squared is whatever 8 squared minus 5 squared is. So I guess we should figure that out. So B squared is whatever 8 squared minus 5 squared is. So 39. And therefore B is the square root of 39, which is actually, I believe, already in as simple as it can be. So root 39. So I'm going to leave it as root 39 just for now. So that's in surd form. Right at the end, when I add all the sides up, I'm going to round my answer right at the end to 3 significant figures. That's going to avoid rounding errors. So at the moment, I'm just going to leave it as root 39. So that's in exact form. Okay, now for the semicircle. So this is going to be half a circumference. So this is half of pi d, right? So if you want the circumference, you use pi times the diameter. So if you remember the circle song, you got pi r squared, sounds like area to me. And if I want the circumference, then I will use pi d. Now, because it's a semicircle, it's a half of pi d. So this is a half of pi times 8. So without using a calculator, this is going to be 4 pi. And so my answer is going to be given to me by 5 plus root 39 plus 4 pi. So this is what I'm going to need to type into the calculator and then round. So 5 plus root 39 plus 4 pi. And to 3 significant figures, that is 23.8. Right, we're just going to have to go with that because unfortunately the mark scheme has a different question 6 in it. So we're going to go with 23.8 because, well, that's the answer. What I might do is just very quickly check to see if I have the answer to that written anywhere else. So that's definitely the correct question 6. And if I scroll down, yeah, they've got the wrong thing in the mark scheme. So that's a shame. We can't check straight away if that's definitely correct, but I'm pretty sure it is. Let's just double check. So we've got 5 squared and 8 squared, so that's 64 take away 25, which is 39. Square root that is the square root of 39. And then half of pi d will be half of 8 pi, which is 4 pi. And then when I do 5 add root 39 add 4 pi, that's what I get. So I can't double check with the mark scheme, but I'm 100% certain this is correct. So if anyone spots anything that's wrong, please obviously just let me know. Right, number 7. Okay, so we've got a trapezium. It's got some algebra in there, so you know that's obviously something you see quite a bit of. And it says all measurements on the diagram are in centimeters, okay, and it tells you that the area is 119 centimeters squared, and it then asks you to show that this equation is true. Okay, so we're going to use the area of a trapezium formula and set that equal to 119 and show that it rearranges to make this. So that's how this is going to work. So what you would do is you would add up the two parallel sides. You've got x plus 6 and then plus 3x minus 4. So let's just simplify that first of all. So that's 4x plus 2. And then what we would do is we would times that by how tall it is. So 4x plus 2 times how tall it is, which is x minus 1. So I might do a little grid method for that. So I'll fit it up here. So 4x and 2 and x and minus 1. So this first answer was add up the two parallel sides. This next part is me timesing that by how tall it is. So this gives me 4x squared, 2x, minus 4x and minus 2. So this is 4x squared minus 2x minus 2. And then what do you need to do next? Well, the last step is to halve that, isn't it? Well, half of that is 2x squared minus x minus 1. If you halve this, well, you have to halve each thing that you're adding up. So you've got 4x squared is halved to 2x squared, minus 2x is halved to minus 1x, or just minus x, and then minus 2 is halved to minus 1, and that is the actual area of the trapezium, isn't it? So let's just recap very quickly. I've added up the parallel sides, I've times by how tall it is, and then I've halved it. Right, and that gives me the area, but we're told the area is 119. Right, that we're told that in the question. So we just have to take away 119 from both sides and we get what the question wants. So minus 1 take away 119 is minus 120, and 119 take away 119 is 0. So that's what we want. And then it says, find the value of x, show you're working clearly. So I'm just wondering, how easy is it going to be to factorize that? We'll give it a go. So we'll see if it factorizes. Otherwise, we would use the quadratic formula. So it's got to be 2x and x, otherwise you don't get 2x squared. And then what you want is you want two numbers that times to make minus 120. That's going to combine with the 2x and the x to give you a minus x. So, well, what have we got? I mean, they've got to be fairly close together, haven't they? So maybe... maybe 50... Is it going to be 15, maybe? Because I'm pretty sure if I do 2 times 8, I'll get 16. And if I do 15 times just this one, I'll get 15. So let me explain my working out here. I'm going to have 2x and 8. 2x times 8 will be 16x. And 15 times x will be 15x. And I'm going to be able to take away the 16x from the 15x to be left with minus x. So this is an example of a one with a little bit of kind of thinking about it. You can work out how it factorizes. So let me just kind of explain where that's come from. So it had to start with 2x and x, because that's how you get 2x squared. And then I'm going to need two numbers that times together to make minus 120. So to begin with, I just worry about can I make 120. And the reason I decided on 15 and 8 was first of all because the number that you're left with is when you add these things up, even after taking into account this 2 here, they've got to be pretty close together. So it can't be something like 60 and 2 or something like that. So I thought, well, maybe it might be 10 and 12, but I can't have two 10s and a 12 combined to make 1. However, I can have a 15 and a 16 combined to make 1. And I just off the top of my head thought, well, let's try 120 divided by 15, because I knew that 15 went into 120. Now, this means that either x is minus 7.5 or x is 8. But if you have a look, x take away 1 is the length of a side. So x can't be this minus, so x has to just be 8. Like, you can't have this answer, right? This answer doesn't make sense. Because x is a length, x has to be positive, right? Or in particular, you look at the x minus 1, you can't make x be minus 7.5. You can't make x be minus 7.5 there either, to be fair, and you also can't make it equal that there either. So x has to equal 8. Now, if you are not kind of confident with factorizing, because this was obviously quite a tricky factorization, I'll just answer this very quickly using the quadratic formula, which I suspect most people would choose to do. So a is 2, b is minus 1, and c is minus 120. Right, so it's a is 2, b is minus 1, and c is minus 120. And so we've got x is minus b plus or minus the square root. So this is a formula you need to try to remember, by the way, because you won't get told it in the exam, all over 2a. So minus b plus or minus root b squared minus 4ac all over 2a. So this is minus 1, which is just going to be plus 1, plus or minus, that's minus 1 squared, take away 4 times 2 times minus 120, all over 2 times 2. And then basically, to cut a long story short, if you type this into your calculator, I know I've obviously kind of squeezed a lot in there, and the calculator is now covering it, so let me just move it over. If you type this into your calculator, literally as is, you don't even need to do any kind of extra work. You can just type it in straight away. So minus 4 times 2 times minus 120. And then on the bottom, 2 times 2. I mean, I know I could type in 4, but I might as well type it in exactly as written. And so one answer is 8. And then the thing you're supposed to change is it was plus or minus this square root. So the other answer is minus 7.5. And then the same idea will apply. You can only pick this 8 because all of these have to be positive because they're a length of a side. So I've shown you two different methods of solving that equation there. One using the quadratic formula and one by me factorizing it. So you want to try to be good at least one of those methods. So, you know, one of them involves you practicing working out how to factorize more complicated expressions, and the other one involves you just remembering a formula, the quadratic formula. So you got to pick which one you dislike least. That's what I would say. Okay, next one. Number 8. So we've got a number line, and it says write down the inequality shown on the number line. Okay, so because that's a solid circle, so it's colored in, it's going to be a either less than or equal to, or it's going to be a greater than or equal to. And we know that the number in the question is -1. And we know the letter in the question is x. And so we just need to figure out which way round is the inequality. Well, 1 is greater than -1, 2 is greater than -1. It's all the x's which are greater than or equal to -1. So you could write it that way around, or you could of course write it this way around. You just want the crocodile, as it were, to be pointing towards the x, because x is any value that's greater than or equal to -1. So all that. You don't need to write both. You can just pick one to write. So p is an integer, so that means whole number, and it says -5 is less than p is less than or equal to -2. Write down all the possible values of p. So on the number line, you would ask about -5, but you would recognize you can't actually equal that because it doesn't have the symbol there. Doesn't have it. So the next available integer is -4, then -3, then -2, and this goes all the way up to and including -2, so that's it. That's the answer. I started writing over there because I thought for a second that that was +2 for some reason, but it just fits nicely over here, doesn't it? So there you go. And then lastly, 5y -2 is less than 18, so you just solve this like a normal linear equation. 5y is less than 16, y is less than 16 over 5. So you can just leave it like that. Y is less than 16 over 5. So there you go. You can literally just leave it like that. Although 5y take away 2, is it a mistake? What was my mistake? Well, I should have added 2. So this is what happens when you try to rush this. Right, my apologies. There you go. Y is less than 4, in fact, because I should have started by adding 2. So let me actually make sure I'm writing my working line. So +2, +2, and then divide by 5, and then divide by 5. Right, okay, next one. There are 9 counters in a bag. There is a number on each counter. So we've got obviously 9 counters. We've got 2 1s, 3 2s, and 4 3s. Carl takes at random 3 counters from the bag. He adds together the numbers on the 3 counters to get his total. Work out the probability that his total is 6. Okay, so how can he get a total of 6 with 3 counters? Well, he could get 2 and 2 and 2. Right, he has the possibility to get 2 + 2 + 2, because he's going to take 3 counters out the bag, and if they all say 2 on it, then they add up to 6. What are the other options? Well, if it's got a 1, it can't then be 2 3s. It also couldn't be another 1, because if 2 of them say 1, then the final one can't be a 4. So if there's a 1 involved, it has to be a 1, a 2, and a 3. If there's a 2 involved, then the first one could be 2. If the second one isn't a 2, then it might be a 3, it might be a 1. So it could be 2 add 1 add 3. In fact, don't we just have all the like the 6 versions of this? So we've got 1 add 2 add 3. Let me write them a bit more systematically. So we've got the 2 + 2 + 2. Then we've got 1 + 3 + 2. we've got 2 plus 1 plus 3, and we've got 2 plus 3 plus 1, and we've got 3 plus 1 plus 2, and we've got 3 plus 2 plus 1. These are the 7 ways that he could add, like the 3 counters could add up to 6. Okay, if, for example, if 2 of them come out, if 2 of them say 3, then already the last one's either going to be a 1, a 2, or a 3. It's not going to add up to 6. So you can have at most 1, 3. You can have at most 1, 1. And if you have any more than 1, 2, then you actually have 3 2s. So that's enough to say that these are our options. So anyway, I'm not sure I've explained that particularly clearly, but hopefully you can see that these are the only ways of getting 3 of these numbers to add up to 6. Anyway, this is where we're up to. So we have to work out the probability of getting a 2, then a 2, then a 2, or a 1, then a 2, then a 3, or a 1, then a 3, and a 2, or, and then there's these kind of overall 7 options. So it's a very big probability tree about what all the different things are. What we've really got is we've just got kind of 7 pathways through the probability tree that we actually care about. We've got the first one being a 2, the second one being a 2, and the last one being a 2. We've got the first one being a 1, the second one being a 2, and the last one being a 3. So all I'm doing is I'm drawing the pathways in the probability tree that I actually care about for answering this question, instead of drawing the whole thing, because that would be absolutely crazy to try to draw that. I mean, even drawing all of this is a bit crazy. But anyway, let's work out what these numbers are that go on here, shall we? So we've got, the first one is going to have probability something out of 9. The second one, there'll only be 8 things left. And the third one, there'll only be 7 counters left. So every single one of these looks like this. Okay, so it just takes a bit of time. I think I can already tell you that there's a little shortcut to this. The idea is all of these are actually going to be equally likely, but I might as well show you the complete solution. So we just need to fill all of these in. Okay, so why are the numbers going down by 1 each time? It's because as I do this, there'll be 1 fewer counter left every time. So every time a counter is removed, it's not put back, remember? Because he's actually taking all 3 out of the bag at the same time, and then he looks at them and adds them up. So, what's the probability the first one's a 2? Well, it's 3 out of 9. Then the probability the second one would be a 2, would be 2 out of 8, because there's 2 2s left. And then the third one being a 2, given that the first and second were both a 2, we're left with 1 out of 7. Right, because we've only got 1 2 left at that point. Okay, what's the probability the first one's a 1? It's 2 9ths. What's the probability that we then get a 2? It's 3 8ths. And then the probability the last one's a 3 is 4 7ths. And then we've got 2, 4, and 3. And this is the idea. If you actually think about this, the 9 times the 8 times the 7 is going to be the same for all of them. And then we just have 2 times 3 times 4, 2 times 4 times 3. Here we'll have 3 times 2 times 4. Every single one of these is actually going to give me the same answer. So I could just work out one of them and then times it by 6. And that's actually what I'm going to do to do it quickly at the end. So 3 over 9, 4 out of 8 for the 3, and then 2 out of 7 for the 1. How many 3s are there? There's 4. How many 1s are there? There's 2, and then there's 3 2s. And then lastly, 4, 3, 2. And so what we're going to do is we're going to have 3/9 times 2/8 times 1/7, and we're going to have 2/9 times 3/8 times 4/7. But we're actually going to have 6 of those, aren't we? So that's kind of like all of those added up. So we'll get the calculator out and we'll see what these add up to. So on the top I'll have 3 times 2 times 1, and on the bottom I'll have 9 times 8 times 7. So that's 1/84 goes there. And then here I'm going to have 2 times 3 times 4, 9 times 8 times 7. The reason I can now just press times by 6 is because swapping the order around in a multiplication doesn't actually affect the answer. So all 6 of these are actually all going to give me this answer here, 1/21. So I'll have 6 of those, so I'll have 6/21, which is of course just 2/7. And so my final answer would be, I would really have added all of these up. So I've got 1/84 plus 2/7. So that's 25/84 as a final answer. Super, right, okay, next one. Highest common factor of 140 in x is 20. The lowest common multiple of 140 in x is 420. Okay, so what you'd want to do is you'd want to have like a factor tree for 140. Like if you think about it, you'd be working backwards to get the answer here. So this would have all started out with factor trees. So we might as well do all the possible factor trees we can. So we've got a factor tree for 140. We're going to have a factor tree for 20. And we'll have a factor tree for 420. Just get rid of the calculator there, sorry. Okay, so let's draw the Venn diagram that we would get. So we're going to have 140 and x, right? Because it's 140 and x are the two numbers. Now it says the highest common factor is 20. So that would have been a 2, a 2, and a 5 kind of written in there, right? Because the highest common factor is the primes in the middle that get times together. And then we'd have the remaining numbers in here, so there'd just be a 7 left over. Do you see that? We would have a 2, and a 5 have gone in the middle, and then there's this 7. And we want the total product, like all the numbers in the Venn diagram, to times together to make 420. Okay, so this 20 is the numbers in the middle, 2 times 2 times 5. The 420 is all of the numbers in the Venn diagram. So do you notice how we've already got 7, we've already got 2 and a 2, and we've already got 5, means we need to put a 3 here. Right, so that we've got this 3. So let me explain what we've done, and is this actually now going to work? Well, first of all, in this circle here, the circle on the left, do all the numbers times together to make 140? Well, yes, they do. They're the numbers here in the factor tree for 140. Is the highest common factor for this particular Venn diagram 20? Well, yes, it is, because we've got 2, 2, and 5 in the middle. Is the lowest common multiple 420 as it needs to be? Well, yes, it is, because if you take all of these numbers in the entire Venn diagram, it all times is together to make 420. So this tells you that x needs to be 60. right? Because 2 times 2 is 4, times 5 is 20. Of course, it's meant to be 20 in the middle there. And then 20 times 3 is 60. So that's one way of working it out. You could also have used trial and error. You could have compared prime factorizations and seen it that way. I like this method because well, it ties directly into doing HCF and LCM using a Venn diagram. So it just turns out that basically x needs to be 60 in order to make that true and that true. Okay, so you've got the 20 in the middle and you've got the 420 all together. Right, number 11. A number is decreased by 15%. The result is 320. What was the original number? Okay, so we've got two ways of doing this. I'll show you both ways. So we're left with 85%. We know that that's 323. So the idea is we want to try to work out what 100% is. So maybe I'll go down to 5% and figure that out. Now here's the thing. To go to 5%, I'm not going to do 10% and then halve it. Because I'm actually starting with 85%, I need to work out what I've divided by. So 85 divided by 5, I have divided by 17 to do this. So there I'm going to divide by 17. So 323 times divided by 17 is 19. So 5% would just be 19. If this is 85%, then 5% will be 19. And then 100%, well, I'll be timesing that by 20 to go back up to 100%. So 19 times 20 is 380. So we've got the answer of 380. We could also solve a little equation. So I'll show you a different way of doing it. So let's call the original number x. We're going to have x multiplied by 0.85 because that's a 15% decrease. That's got to be 323. So x is just going to be whatever 323 divided by 0.85 is. So if this is all supposed to work, then this is supposed to be, of course, 380. So you pick whichever one you prefer as a method. Right, number 12. We know altogether that these numbers have to add up to 32, so that's the first thing I'll do. And they're asked, do they have a desktop computer, a laptop, or a tablet? And then we've got a bunch of numbers. And so we actually have to look at the bottom and work our way up because it says 5 students have all 3. So I'm going to put 5 in the middle there. 7 have both a laptop and a tablet. So the laptop and a tablet is this part here. It's this part here that overlaps laptop and tablet. And the total in there is supposed to be 7. So since we've already got 5 there, we're going to have to put 2 there. And then it says, okay, 11 students have a desktop and a tablet. So that's this part here. That part there is supposed to add up to 11. So that has to be 6. 9 have a desktop and a laptop. So that has to be 4 to make this part add up to 9. 16 students have a tablet. So 6 and 5 is 11 plus 2 is 13. So there's another 3 students who just have a tablet. 17 students have a laptop. So that's 9, 10, 11 there. Plus an additional 6 makes 17. And then 19 students have a desktop. So 6 and 4 is 10. Add 5 is 15. Add an additional 4 students to make this total circle be 19. And then we must make sure we work this part out here because there are some students who don't own any of these things. So I'm just going to add all of these numbers up. So that number there is just 2, isn't it? There are 2 students who don't have any of these things. And then it says, okay, one of the students with both a desktop and a laptop is chosen at random. So desktop and laptop is this part here. Let me just see if I can do that even slightly more neatly. There we go, try my best. So one of the students with both a desktop and a laptop is chosen at random. Find the probability that this student also has a tablet. So that would be 5 out of 9. Right, because there are 9 students who have both a desktop and a laptop, of which 5 of them have a tablet as well. So it is 5 out of 9. Okay, number 16. We've got a quadrilateral ABCD, so it's this shape here all the way around, and it wants the area of it. Okay, so we are going to use the sine rule although, actually, can we use the sine rule for that? No, I don't think we can. I think in order to answer number 16, we need to use the cosine rule, which unfortunately I was going to do with you in the week before half term. So my apologies that this is a question that's kind of there for you to have a go at, even though you haven't done the cosine rule. I'll still answer it because I am going to do the cosine rule with you on the first and second lessons back. So anyway, the reason that we have to use the cosine rule is because we cannot use the sine rule. So as I began thinking, oh, I'm going to use the sine rule, I straight away, oh look, I don't have these angles opposite the known side, so I cannot use the sine rule. So instead, what I'm going to do is I'll just make a little copy of this triangle here. So there's 1, 3, 2, there's 11.8, and there's 7.4. And then how you use the cosine rule is I call that A and A, and then this might be B and C, doesn't really matter. And then the cosine rule says A squared equals B squared plus C squared minus 2BC cos A. So it looks pretty horrible, but we can actually substitute straight into this. So this is 11.8 squared plus 7.4 squared minus 2 times 11.8. Just notice the calculator's in the way. 2 times 11.8 times 7.4 times cos of 132. So we do need the calculator now, I'm afraid. Let's move it over here. I want to type in 11.8 squared plus 7.4 squared, take away 2 times 11.8 times 7.4 times cos of 132. So this is 310.8569691, and then I need to square root that to get what A is. So A is 17.63114. So I'm going to be as accurate as that. So what that means is that is 17.63114. And then I'm kind of nearly done, okay? Because I've got the area of the top triangle, this ABC. So the area of triangle ABC is going to be 8.2 times 17.63114 halved. And the area of the bottom triangle, so triangle ACD, is we're going to use the sine rule, the area of a triangle formula, right? So that's what we're going to do. Area of a triangle formula with a half times 11.8 times 7.4 times sine of 132. And so I'm just going to get both of these answers and then add them up on the calculator. Okay, so let me type it in as like in total. So 8.2 times 17.63114 halved. So that's just base times height halved. And then that's the top triangle. And then plus a half times 11.8 times 7.4 times sine of 132. And then to three significant figures, that is 105. So my apologies that I've asked you a question there that uses a formula you've not been taught yet. However, that's going to be put right very, very soon, because of course that's literally, well, by the time you see this video, it is actually what you've done in class. Right, number 17. Y is AT squared minus 2AT. X is 2A root T. And then it says express Y in terms of X and A. So what this means is we want to eliminate T from the Y equation. Okay, so what that means is instead of T's, I need something with X's and A's. So let's start with X equals 2A root T. Let's square everything to get rid of this square root. So X squared is, well, if I square a product, it's each of the individual things getting squared. So that's 4A squared T, which means T is X squared over 4A squared. That's super important, because once we've got this, we're just going to substitute that into the Y equation. So instead of AT squared minus 2AT, you've now got A, and then we've got what? X squared over 4A squared getting squared, minus 2A lots of X squared over 4A squared. Then we just have to figure this out. So this is A lots of X to the 4 over 16A to the 4 minus 2A. So in that situation, it's now we can just write it straight away as 2AX squared over 4A squared. And then we can do some simplifying. So let me just come up here. So I've got AX to the 4 over 16A to the 4 minus, let's divide top and bottom by 2 and divide top and bottom by A. So I've got X squared over 2A. And here I can divide top and bottom by A, and I actually think that this is now the final answer, isn't it? So X to the 4 over 16A cubed minus X squared over 2A. I think that's the final answer. X to the 4 over 16A cubed minus X squared over 2A. Fantastic. Right. So the important thing to do was to work out what T equaled in terms of A and X. So it's in this box here. You put that into this. Now to square a fraction, you square the top and square the bottom. To times a fraction by something, you are just timesing the numerator. So the 2A goes on the top, this A just goes on the top. And then you'll do some simplifying, right? So for example, I can divide top and bottom by 2, and I can divide top and bottom by A. That leaves me with X squared over 2A. Here I can divide top and bottom by A, so that leaves me with X to the 4 on the top, and then instead of A to the 4, it'll be A cubed. Right, and then final question. Work out the proportion of the components with a lifetime between 1 and 6 years. Okay, so since it's a proportion, it means it's out of the whole thing, which means I do actually need to know what the whole thing is. So I want the total area, because in a histogram, area is frequency. So I'm just going to write that down. Area is frequency. So let us do 2 times 0.6, so that's 1.2 in total. Right, I'll say that again. 2 times, why am I saying 0.6? Do you see the scale there? It's not 0.6 at all, is it? So that's very, very sneaky, isn't it? Because look, that there is 0.1. So it must be going up in 0.02s. So that's 0.1. This has a height, so let's just write down what the heights are. So it's like 0.02. In fact, you can also see that it must be 0.02 because there's 10 little squares and it adds up to 0.2. So it's 0.02 is each little square. So this is height 0.12. This has height, oh, it's not the easiest to see. That's another 1.2 on top of that 0.2, so that's 0.32. This one here has height, so that had 0.32, 0.34, 0.36, 0.38. This one here has a height of 0.52 because it's 0.02 above 0.5. And then this last one has a height of, well, there's 0.1, 0.12, 0.14, 0.16. Okay, so now we're in a position to actually just compute this totally, right? So we've got the total area, which is the total frequency, will be 2 times 0.12, add 1 times 0.32, add 1 times 0.38. So each of these are just areas of rectangles. Add 1 times 0.52, add 2 times 0.16. So I guess with the calculator, and to be fair, we can save a bit of time, can't we? Because we don't need to write 1 times all the time. So 0.12, add 0.32, add 0.38, add 0.52, add 2 times 0.16. So that's 89 over 50, but I'm just going to write it as a decimal 1.78. And then the required area goes between 1 and 6. Right, so it's just this part here. So it's actually the kind of the same calculation, except it's now 1 times 0.12 at the beginning and 1 times 0.16 at the end, because instead of a distance of 2 along, it's just a distance of 1 along. So, well, I'll write it down, but of course you can save a bit of time. You don't need to write all of this. But what I'm doing is I'm adding up now all of the, like, the blue rectangles, areas, and I can save myself a bit of time, because this previous answer, if I just take away a 0.16 and I take away a 0.12, I should get the answer that I'm looking for, which is 1.5. And so it's 1.5 out of 1.78. which equals, well, whatever that equals. So 1.5 over 1.78. So 75 over 89. Oh, I mean, that does not look right, does it? But it is right. 75 over 89. They allow you to round that to 0.84. But anyway, that is the actual answer is 75 over 89. All right, yeah, and my apologies, there's the calculator showing that. So 75 over 89. Right, so the reason that histogram question was unpleasant was just because the scale is so unpleasant. You get all of these areas that are horrible, like decimals, but that's okay. It's just the same method, the same ideas, the same kind of overall method, right? I've worked out the total area, so that gave me 1.78. I worked out the required area, which was the stuff between 1 and 6. And then the proportion is that out of that, right? So it's, when you put that in the calculator, it's 75 over 89, which is just a way to leave your final answer. So I think the trickiest part of all of this question, as much as anything, is working out what the scale is. Well, it's 10 little squares to make up 0.2. So you could do 0.2 divided by 10, which tells you that it goes up in 0.02s. Right, just a very quick recap through each question then. So I think that one wasn't too bad. That one should have been fine. This one, as long as you remember, well, as long as you read the question really carefully and remember speed is distance over time, I think this is not too bad, because yes, it's not very nice if this is in hours, but it wants it in minutes. So you want to obviously times by 60 to go from hours to minutes. So you get a nice answer then. Okay, so you can definitely practice solving simultaneous equations. These simultaneous equations are not too bad at all. Compound interest. Again, something that you can revise, do a bit of practice of, and then should be okay. This one, if you can remember Pythagoras and you can remember pi d, then you should be okay with that. This was quite tricky. As long as you remember the area of a trapezium, and in particular remember the method for it, right? So you add up the parallel sides, you times by how tall it is, then you halve, that will be the area. So if you actually follow that method, you actually get the exact equation that it's wanting. Okay, so this is just inequalities and remembering what an integer is. I remember I made a little mistake here, so you know anyone can make a mistake. So especially if you're rushing, so don't rush. That's the lesson there. Okay, number 9. So number 9 was quite difficult to explain through doing me answering it on a PowerPoint slide. What you've got to think is you've got this really big probability tree with, well, 3 options, then 9, and then 27. It's a huge probability tree, of which we're only interested in 7 paths, because we're only looking for the pathways where the answer adds up to 6. So after a bit of thinking, you realize that these are the only ways that can happen, and then you work out what would have been on the branches and go from there. This is not so bad when you have seen questions like this a few times, so we'll do some more practice of those. That's not a problem. That's pretty standard. That's pretty standard. That's something that we haven't actually done yet, so I apologize for that again, but it's something you'll see very, very soon. This is probably the hardest question, apart from this, because obviously not sure what to do with that, but this is the hardest question, I would say. And I also know I went through it quite quickly, but that's because there's not really a lot to say about it. Okay, there's not really a lot to say about it. Square that and make t the subject. That's going to be t in terms of a and x. And then if you substitute that in there, you'll have y in terms of a and x, which is what the question actually asks for. So there's actually not much to say about it other than to just do it and to remember how to simplify fractions. Okay, and then the last one is just a pretty standard histogram question, except the scale is not as nice. Okay, instead of going up in, you know, ones, 1, 2, 3, 4, 5, 6, it's going up in, well, the little squares are 0.02s, so it does make it a bit harder. But anyway, that was that. Any further questions? Anyone, you know, have anything they want to ask? You know, you can email me or you can ask in class, and I will see you for the next one. Thanks.